In 4.1, we learn about exponential functions. First of all, what are exponential functions? Well, the basic idea is that an exponential function has the variable in an exponent. Here are some examples. F of x equals 2 to the 3x, or y equals 5 minus 1/4 to the x. Notice that the variable is in the exponent. Don't confuse these with power functions. A power function is something like f of x equals x squared. In other words, it's x to a power. These are not the same as exponential functions. So this is not an exponential function. Yes, it has an exponent, but the variable is not up there in the exponent. So contrast that with an exponential function, which looks like, well, let's just go with 2 to the x. And so this is a constant base raised to a variable power. Whereas the power function is a variable base raised to a constant power. Here's a definition. The function f of x equals b to the x is called the exponential function with base b. This is the most basic exponential function, and it'll be our building block for other types of exponential functions that we'll see. I should mention the base b cannot be negative. Not because you can't raise a negative number to a power, it's just that's not part of what we're calling exponential functions. And the reason we're not allowing negative bases is because of, here's the problem that can arise with a negative base. Suppose f of x was negative 2 raised to the x power. What would f of 1/2 be? Well, that would be negative 2 to the 1/2 power, but remember, 1/2 power is a square root. So if we have a negative base, there's a problem where we might end up needing to square root a negative, and we can't do that, right? This square root of negative 2 does not exist, or at least it's not a real number. So for exponential functions, we're just going to use positive bases so that we don't run into that problem. The base b also cannot be 0 or 1. And again, it's not that you can't take 0 or 1 and raise it to a power, but suppose we said, oh, hey, my exponential function is 0 to the x power. The problem is 0 to the x power is always 0, no matter what x is. So this is really just a constant function. And we'll see when we look at graphs of exponential functions that the graph doesn't look anything like a constant function. And we don't want to call a constant function an exponential function. We want to keep those separate. We run into the same problem with if our function was 1 to the x power. That's perfectly okay. You can define a function to be 1 to the x power, but anytime you raise 1 to a power, it doesn't matter what the power is, you're always going to get 1. So again, this is really just a constant function. So we want to keep that separate from exponential functions. So it's not that there's anything wrong with either of those, it's just that we're not calling them exponential functions. So basically, b has to be a positive number other than 0 or 1. And that's our basic exponential function, the exponential function with base b.